The second method we have to solve partial fractions is the cover-up method. We can use either method, but cover-up method is easier. So let's take an example. How about I have 2x plus 7 over x minus 1 x plus 3. The denominator is again factorized. I'll make another video if the denominators are not factorized. In this video, we are just covering the basic concept. So I can write this down. The first step is the same. So I'll write this down as a single fraction. So this would be something like this. X minus 1 multiplied by x plus 3, and a would be multiplied by x plus 3 x minus 1. You need not use different colors. Use a single color on your exam paper, but in this case I'm using different colors so you can remember to multiply and realize that the denominators cancel out. So I am left with ax plus 3 plus bx minus 1 is equal to 2x plus 7. So in the comparing coefficients method, we compare like x with x and the constant with the constant. But in this case we won't. What we will do instead is assume a value of x. Assume a value of x. So let's take x as 1. And why did I take x as 1? Because I know when I'll take x as 1, this part will automatically cancel out. So I have this. Plus b, 1 minus 1 is 0. Thus I have 4a is equals to 9, and a turns out to be 9 over 4. Similarly, for the value of b, I can substitute this x as minus 3. Why? The significance is that a will cancel out and I'll only be left with b, and I have to find the value of b. So when x is equals to minus 3, I have to show the working. So it's 2 minus 3 plus 7 is equals to a minus 3 plus 3 plus b minus 3 plus minus 1. So I am left with minus 4b and 1. And b turns out to be minus 1 over. I cannot leave my answer in this form. I'll have to leave my answer as partial fractions, and my answer would be something like minus 1 over 4 x plus 3. Just confirm the denominators, and yes, this is my answer. Now, our second example for cover-up method is our second last example. So we have EG2 as 4x plus 1 x minus 1 x minus 2. The denominator is a factorized form again. I'll speed it up things. So I have something like this. If I write this as partial, I know the denominators will eventually cancel off if I cross multiply. So I'll skip that step, and I can write this as ax minus 2 plus x minus 1 is equals to 4x plus 1, because I repeat the denominators are to cancel off eventually when I cross multiply. So let's assume the value of x to be 2. So when x is equals to 2, 4 into 2 plus 1 is equals to 2 minus 2a plus 2 minus 1b, and b turns out to be 9. Make a column so the examiner can understand your work. The second value of x, assume it to be 1. So b cancels off. So when x is equals to 1, I have a 1 minus 2 plus b 1 minus 1, and 4 into 1 plus 1 plus a turns out to be minus 5. I cannot leave my answer in this form. I'll have to leave it as partial fractions. So my answer turns out to be something like this. If you have brackets in the denominator, it doesn't matter. Just a second. And then it's our last and final example. 2x plus 3, x minus 1, x plus 2, x minus 3. The denominator is again in factorized form, but I have 3 factors. It's a cubic equation in the denominator. The sequence of steps will remain the same nevertheless. But I'll have 3 fractions here, a, b, and c, over x minus 1, x plus 2, and x minus 3 respectively. Now I need to cross multiply. And when you're cross multiplying, the only thing you have to compare this fraction is, let's say for example, is with this. What does this fraction not have? So this fraction does not have x plus 2 and x minus 1. I'll multiply both these with this. This fraction does not have x minus 3 and x minus 1. I'll multiply this. And this fraction will only be multiplied by this, since these two do not exist. Consequently, I'll have something like this. I'll skip the cancelling the denominator step again. B multiplied by x minus 1, x minus 3, since they do not exist in that fraction. And C multiplied by x minus 1, x plus 2, since this does not exist in this. And I have 2x plus 3 left here after the denominators as well. So first of all, be smart. I repeat, be smart. Let's assume the value of x to be minus 2. So this a cancels off and c cancels off 2. So when x is equals to minus 2, I have 2 into minus 2 plus 3, b minus 2 minus 1 into minus 2 minus 3. So I have b minus 3 minus 5, and I have minus 4 plus 3. So minus 1 is equals to 15b, and b turns out to be minus 1 over 15. So I have a first value. And and simultaneously, you should also appreciate the fact that cover-up method is much faster than comparing coefficients. So for the second value of x, let's assume x to be 3. So this A and B cancels off again. So in this case, I have 2 into 3 plus 3 is equals to C, 3 minus 1, 3 plus 2. So I have 10C is equals to 9. And C turns out to be 9 over 10. And then I'll be left to find A. So for A, what have we not substituted? So I'll substitute X as 1. So when X is equals to 1, I have 2 into minus 1, sorry, 2 into 1 plus 3 is equals to A, 1 plus 2, 1 minus 3, and A is 3 into minus 2 minus 6A, and on this side I'll have 5, 5, and A turns out to be 5 minus 5 over 6. And then I'll have to leave my answer as partial fraction again. So I'll copy this. So my final answer would turn out to be something like this. Just a second. So I have minus 5 over 6. Let's write this in red. And I have B as minus 1 over 15. And I have C as 9 over 10. So this is my final answer.